Okay, we can start. Hello, this is Service Discovery and Configuration with Consul. The talk is a bit generic about service discovery, but also covers some specifics about the Consul software application itself. Who am I? I'm Carl Johnson. I help manage technology operations at OpenX. We are a digital ad platform in Pasadena. I've got my email addresses up there, personal and work-related. If you have any questions, I'm happy to answer them via either email address. And I would be lacking if I didn't put in a plug for the fact that we're hiring. There is the URL. If you like what you hear here and you're interested in more of this, OpenX has a variety of jobs available. Even if you don't like what you hear, OpenX has a variety of jobs available. Before I start, quick thank you. I borrowed some elements of these slides from Armand Dodger. I actually don't know how to pronounce his name because it's all been over email, but he is the primary author of the Consul application. He works for HashiCorp, the company behind the open source application, and also Chris Varneren, who I believe is in the audience. No, maybe not. Yeah. He is a site reliability engineer I work with closely at OpenX, and whereas I've kind of been the idea man, he's really found really investigated a lot of the details and nooks and crannies of Consul and is deploying it in production really in 2015. So I have a lot to thank him for in regards to some real world details of Consul. So, service discovery, it's in the title of the talk, but what is it? Well, it's all around you. Bluetooth, if anybody's paired their phone to their car, you have used service discovery. Your car seeks out music providing devices or storage providing devices using the Bluetooth protocol. If you had to use a manual method without service discovery, you can imagine like typing your phone's MAC address or system ID or something into your car's console. That would be atrocious. So that's why this sort of technology is there. DNS, SD service discovery, or more commonly now known as multicast DNS, also known as Bonjour. That's the old Apple name for this protocol. Apple uses this extensively. It's really an open protocol, but when an iTunes client discovers other iTunes clients or servers that are providing music or audio, that's service discovery in use. It's basically involving DNS messages that advertise a specific type of service. UPnP, Universal Plug and Play, your home router, your Linksys router at home uses that. It's riddled with security vulnerabilities, so it's probably off, but it's good in theory, and it allows your router to advertise itself as a router, so your computer can find it and publish, say, a NAT mapping, so you can play, I don't know, Half-Life 2 or whatever is popular now. DHCP, Pixie Boot, that's a very crude example of service discovery, but something those of us in the sysadmin world are probably very familiar with. Active Directory, that's just LDAP and Kerberos essentially, but there's a way that a Windows computer or any Active Directory client discovers the location of Active Directory services, and that's actually similar to multicast DNS, but that is using service discovery. And this will probably be the only time you hear IPX mentioned at scale. Novell NetWare used service discovery extensively. So just like cloud computing and containers, everything old is new again. And Novell NetWare in the IPX protocol had SAP server advertisement server advertisement protocol that allowed, say, your client on the LAN to find a file server or find the printer or what have you. And it was actually pretty graceful. So we've kind of come full circle in some respects. Why do we need service discovery? Well, I started my career as a network engineer, and now I'm involved more in general systems architecture. And it's always been a different case at every company I've worked in how multiple instances of one software application talk to multiple instances of another software application. There's been various degrees I've encountered of graceful and horribly manual ways to do this. And inevitably it becomes a manual, complicated or expensive. And by expensive I mean not just money, but CPU, horsepower, You know, you might build out a whole software application to do this, but that's expensive still from a labor, from a mind share, from a CPU standpoint. So let's look at a simple reason for service discovery. The most simple kind of multi-server application I can think of, probably everybody has deployed this. Your typical LAMP stack looks like this. You've got a web server like Apache or Nginx. Maybe you've got an application server like Rails, Django, Tomcat. It's all on one box. You've got a backing database. Nice and simple. Hey, you just hard code the database and the web server and application. That's as simple as it gets. But now we want to scale it out. We've got 25 hosts. And they can't all talk to a single database server, nor do we want them to in case that database server fails. So now we've got 5 database servers, and only one you can write to because that's the master. The other 4 are read-only, which is fine. They're read-only slaves. Maybe we don't do too much writing, so we're okay with that. But now, you know, it's getting a little bit more complicated. You've got multiple systems that need to talk to multiple downstream services. So the classic example, this is kind of outside of AWS and cloud options, but really even applies with Elastic Load Balancer, I think, in AWS, is to have a separate load balancer. Well, okay, now you have to manage that separately. You have to keep that configuration up to date. It needs to have 2 services defined, one for the master, one for the read-only, and it needs to keep track of what nodes are currently members providing what services in the database. Well, here's some problems with that. The load balancer is single point of failure, especially if it's a hardware load balancer like F5, NetScaler, A10, you know, numerous other commercial options. So you better buy 2. It's got to be highly available. And how it does that HA is probably specific per vendor. You're going to have to figure it all out. You're going to have to train network engineers or other technicians on how to make it highly available. If you outgrow your load balancer, especially if it's a commercial load balancer, we joke at OpenX that some commercial load balancers have a slot on the side of them that you feed money into to get more performance out of. So yeah, feed $100 bills into the load balancer. That's how you scale it. Wow, there's like a techno club that opened up next door. Awesome. Basement talks, okay. Automating a commercial load balancer, it can be done. Actually, we do it at OpenX. It's not the most fun thing in the world to do. You're certainly not going to test it against your production load balancer, so you've got to have another load balancer to test against, or a software equivalent thereof. You might have to mess with SNMP. They might not have up-to-date, you know, APIs. It probably isn't REST. It might be SOAP. It might be something proprietary. Who knows? It's no fun to deal with. And this is consistent with hardware and software load balancers. Health checks can be good, but are often bad. The default is TCP half open. I don't know if everybody knows what a TCP half open health check is, but it's terrible. It's just, is the port up or not? It doesn't necessarily mean the application is healthy. You know, your application might certainly be listening on port 80, but it might not be actually returning a web page on port 80. But your load balancer is still going to send traffic to it anyway. So here's the second option, and if you're in Amazon or another cloud-based solution, this might be your only option, which is to run a local instance of a software load balancer. HA Proxy is a popular option there, and that does the job, kind of same as the commercial load balancer. You don't have to spend much money. It's open source. Like I said, in some cases, if you're not running bare metal, which is the case more and more these days, it's your only option. But you still have to keep that configuration up to date. That doesn't change. And you still have the health check problem. It operates the same as a hardware load balancer in that respect. Okay, so we're going to keep the configuration of everything in sync. We already manage the web server and the application server and the database with configuration management, so we'll just manage the node membership list in HA Proxy with configuration management. Puppet, Chef, Ansible, Salt, what have you. Popular way to do it. All right, great. That's pretty good. But you still need proper health checks. That, again, didn't change. It's really a department or a company cultural thing to do a good job enforcing proper health checks. And by that I mean actually posting or providing the synthetic health of the application to the load balancer rather than low-level network uptime such as, you know, layer 3 and 4, which is what all half open does. You've still got to keep it up to date. You might build out a great system that links host names to services. If you've got foobar application and, you know, H1 host is a member of foobar application, great. Maybe you check that in manually. Maybe you've got a wiki page that manages that. Maybe you check that into version control. Maybe you've got an inventory system that automatically updates configuration management and pushes that all out. That's actually excellent, but it's probably complicated, and it's very customized, and it's fairly heavy. Every time you do that, you're probably committing to version control. There's this whole set of events that go into motion. Configuration management still has to be highly available. That can't go down, just like the load balancer can't go down, or you're stuck. So you better test that out extensively. Multiple masters, you know, if you're using SALT like we are at OpenX, you know, they recently launched multi-master support. You know, we're deploying that because the masters absolutely have to be up or your environment is frozen. And then this is more philosophical, but in configuration management, you've kind of got the configuration management system that everybody has to go configure, and then you've got your applications. And if you want to do DevOps, which all the cool kids are doing these days, then you've got to train your developers on how to use configuration management. That's no easy task. And the whole thing is just fairly complicated. Now, HashiCorp uses this term called N-tier architecture. Maybe that's a common term, but I hadn't heard it before. I think it's a good way to summarize what happens when you go to a true service-oriented architecture and you go from beyond those two applications. And in this case, we've got 12 different applications, but it can scale to 100, 200, 500. This is another way of looking at a typical enterprise architecture. In my experience, I'm so excited I had a chance to use my favorite animated image in context. This is in serial, so it's not truly, well, it might be representative of certain architectures, but this is a serial architecture, so I hope nobody's doing this. But this is a service-oriented architecture where each component is doing its one thing and its one thing well because the ball is getting to the guys at the bottom for them to drop. So I would call this central control fairly monolithic. A central system is controlling everything. It's the brains. It's great. Configuration management, there's a reason everybody uses it. You're still going to use it for building machines, for certain configuration on systems. You're going to need it for whatever service discovery system you do launch. It's still got to be reliable and scalable, like I mentioned. There's the training overhead, the hooks, triggers, everything's complicated. And then, frankly, when any one thing is doing a lot of things, kind of reminiscent of like the systemd kind of FUD that's in the Linux community right now, I know my spider sense goes off. I like the Unix philosophy of do one thing and do it well. These platforms, these configuration management platforms just are everything in the kitchen sink is the way I feel. And I think you can do some things in them, but you may not want to do everything in them. So here's what it would look like with service discovery. Let's go back to the simple two-tier architecture. We've got an authentication server and a database that has the users it's authenticating against. I use the term subscribe and publish because I think of this like a pub-sub system, a pub-sub piece of software, essentially. You want your downstream services to publish their existence and health, and you want your consuming services to subscribe to that membership. The database says, I have this service, it's called UserDB. Oh, the tag on it is read-only, by the way, and I'm healthy. And then the consumer upstream says, I need to know all the systems that are providing the read-only tag for the UserDB service that are healthy. And you can see that this is a very distributed model where each consumer and publisher, or subscriber and publisher, owns its own role in the architecture, owns its own place in the architecture. There is no central brain of how it all works that can be difficult to configure. Any system in the architecture is empowered to subscribe, and any system in the architecture is empowered to publish. So what are our options to implement this? I'm not going to go into great detail on the things that aren't console because that's in the title of the talk, but there are a lot of options out there. There's Zookeeper, which I've had a little bit of experience with. etcd, that's popular from CoreOS, and it's got its place for sure. DoozerD, I've never used that actually, but in researching these, basically these systems are just key value stores. If you want to do service level abstraction on top of them, you've got to use a third-party tool or you've got to write it yourself. That's all it is. I mean, might as well be, MongoDB or Riak or essentially any other sort of key value storage system. It is simple, which is a good, well, some of them are simple. etcd is simple. Zookeeper is not simple. Zookeeper requires thick client-side libraries. When it's all working and it's just sort of plug and play, when something needs Zookeeper, that's all well and good, but we've at OpenX troubleshooted cases where Zookeeper is not working correctly for custom written things, and it is opaque, is the way I would put it on the server side. So it's complicated and opaque, not something I particularly like. SkyDNS is pretty cool. It's fairly new. It is aware of services. It doesn't have a lot of health checking though, so while you can publish service membership, you might not necessarily have the greatest level of detail in whether those services are healthy or not, and it's not multi-data center aware. It does have regions, but there's some workarounds you have to do to kind of make it work over a WAN. Surf is also from HashiCorp, and actually Consul uses some elements of Surf. It uses Surf libraries for its gossip-based system. It does have the concept of nodes, not really hosts. Nodes are kind of the abstraction it uses, so it does go beyond key value. But again, it doesn't have much health checking, doesn't have the concept of services. Everything is a node. You can run it over a WAN, but performance will suffer. So still not ideal. On paper, Consul looks pretty awesome. It's strongly consistent, which means basically it sacrifices accurate data, or it sacrifices availability for accurate data. So you can trust it as long as essentially the service cluster is up. It's got a complex gossip system. It uses the Raft consensus algorithm. It uses the Surf libraries for that. My favorite thing about it, and the reason I'm speaking about it, is it's opinionated. It tries to solve the problem of service discovery by abstracting services. You don't have to build anything else on top of its key value store because services are a tier 1 supported object in the system. It also has health checks built into it, attached to services, which are compatible with Nagios or Icinga or whatever else you might be using. That, of course, can kill two birds with one stone if you already have some local health checks using that type. And it's got a very simple configuration. You don't have to write anything against it. Basically, you can configure the entire thing with a few JSON configuration files. It's not, yes, it is a platform you can develop on, but you can also roll it out really in a matter of minutes or hours without a lot of fanciness or coding. Oh, it's also got multi-data center support. Essentially, you define a data center string in the cluster, and then the namespace is scoped for each cluster according to that string. So it's aware of other clusters that may exist over the WAN or across data centers, and there are queries possible between those multi-data center clusters, but it's kind of aware of the real-life use case where queries between data centers are rare but can occur. So let's hear more about Consul. It's got a .io domain name, which automatically makes it awesome as far as I can tell. It's by HashiCorp. Those are the same guys that make Vagrant. That is super popular, so I'm sure many of you have heard of that. They also make Packer, which is a tool I actually learned about through Consul. It's a fairly interesting imaging, kind of a portable imaging system as well. They've got an active community on GitHub. I'm on their mailing list. It's super popular. I've gotten some good questions answered there. They just released version 0.5. The slide used to say 0.5 release candidate, but I think yesterday they released version 0.5. So they've been releasing pretty rapidly. There's a lot of active development. And HashiCorp does use it in production, so they say, to power their Vagrant cloud, which I haven't personally used. But this is what the architecture of Consul looks like. You can see two data centers in this diagram. The important differentiation in Consul is client versus server. A server cluster is required All of this uses the same software binary, um, but you essentially run the binary in server mode versus client mode. I'll cover kind of what each does and what that looks like, but basically you've got your server cluster, a leader is elected using the consensus algorithm. They're kind of the brains of the cluster, and then anything that wants to participate in service discovery or configuration or its other functions also runs the console binary agent, and it's in client mode. And you just point it to any other member of the cluster, client or server, and due to kind of the gossip-based algorithm, it discovers the entire cluster. So it's fairly easy to spin up. You don't have to have a kind of snapshot of what the entire thing looks like. You can piece it together peer-to-peer in a peer-to-peer basis. And then there's different levels of gossip that occur. It differentiates LAN gossip from WAN gossip. It keeps WAN communication to a minimum, kind of only as needed. But the LAN gossip is where it's fairly heavily used. It's written in Go. Like I mentioned, there's one software agent per machine. That's run in client and server mode. Just a simple, really like 2 to 5 line JSON configuration file will configure all that. So it's super simple. HashiCorp, the console folks, recommend 3 to 5 servers per data center in a cluster. We have found 5 is the way to go, because if you lose 1 out of the 3, bad things can happen. It's a long story, but trust me, 5 is better. It doesn't demonize, which I guess is a new trend these days, especially with popularity of containers, systemd, that sort of thing, supervisor D. You can run it with if you're not running a systemd-based system or a other sort of kind of Uber process. And then it listens by default on several ports. The most important for our purposes being the client listening ports that you'd use, which provide HTTP and DNS services, which I'll demonstrate in a minute. But let's start at the server. Those are the brains. Those maintain state for the entire cluster. All of the queries for the service discovery functions, the configuration values, the key value store, all the queries wind up at the servers eventually, forwarded on from the clients. Like I mentioned, it uses the RAF consensus algorithm, and it does all the WAN communication. Basically, the administration is really simple using the gossip protocol. Like I mentioned, any one peer to join. It's just console join IP or host name, and you're part of the cluster, whether there's one other member or 500. It will automatically discover the server portions of the cluster. It's got a version protocol, which is pretty important for backwards compatibility. That makes upgrades a bit simpler. You can see in the screenshot kind of everything I'm talking about here, where the software agent itself is versioned as well as the protocol version. So, basically, if you do a rolling upgrade and you maintain backwards compatibility of the protocol, they keep this in mind to be ops friendly, essentially. All the events that occur are peer-to-peer. HashiCorp claims, even across thousands of nodes, it will always be sub-second delivery to requests. We will certainly find out at OpenX. I don't have an answer for you yet verifying that, but that's the claim. And the cool thing about the consensus algorithm is no matter how many members there are in the cluster, the server load remains steady. So that's why they can scale so heavily. It's kind of the magic of the gossip protocol and minimizing communication to more of a push versus pull mechanism. But this is what a typical console client looks like, a publisher of a service. Once the console agent is running, it loads basically star.json in etc console.d, and this is an example MySQL service because I think everyone can probably identify with that. This is a system that's providing the UserDB service. We've given a tag called RO, so in that simple diagram, this might be one of the 4 read-only slaves. We're listing the port that the service is listening on, and then where this gets interesting is basically an array of health checks available to the system, or basically an array of health checks attached, or I'm sorry, actually not an array. There's one health check per file defined, I believe. Or maybe it can be an array. Sorry, I forget the details there. But this is an example of a custom Python script that's checking, well, it's MariaDB, not MySQL in this case, but it's running every 10 seconds. And it's providing its membership and health to the console cluster so that subscribers or consumers of that service can query it. And this is an example of querying that published service name or membership via DNS. This is querying basically localhost in that port I listed earlier. I think it's 86 or 8500. But you can see it's tag.servicename.service.console. That's the default domain name. So by using, and that returns the IP of the single member of that service. If there were 4 or 10 or 500 members of this particular service name, then it would return a round-robin multiple A-record result for that DNS query. That doesn't give you the port it runs on, though. That's becoming more and more important with ephemeral containers that kind of randomize their ports by default. So we might want to make sure that we know what port it's running on if it's not the default MariaDB or MySQL 3306. In this case, it is. But you just query the SRV type or service type of DNS record here, and that gives you additional information. You can see the port number is returned in the DNS response. So that's pretty powerful, the fact that you can do this with DNS. I mentioned all this stuff about HA. Yep, question? So what are you querying here? Is it the console server? Yeah, it's not as clear here. I probably should have listed the fact that it's really what it's doing here is it's dig at 127.0.0.1, and I think it's port, what was it? There you go, 8600. So yeah, it's listening on localhost. So basically all the operations take place to localhost for the most part. Anyway, I mentioned all that stuff about HA proxy, but it's optional. The power of DNS means your application can just directly use the DNS value. If you've got that upstream application server that needs to talk to the database host, if your application is smart enough to use multiple A records returned from the DNS query, then great. Maybe it can use all of them and be aware of all the downstream service members. Or maybe it's not smart enough, it can only use maybe the first A record returned. That's fine too, because Consul implements round-robin DNS so that every time you query that DNS record, it's cycling through, it's not randomizing, but it's round-robin cycling through the IPs of all the members of that service. So you can imagine that that becomes a pretty simple architecture. And then, as you can imagine, as we're publishing these services, if that health check, that Python script we were running, starts to return a bad value, it is immediately, that node is immediately deregistered from the service. So upstream clients stop using it, theoretically, if obviously, aside from session handling of the upstream client, which is its own job, but it can immediately occur, which is pretty compelling versus configuration management, which might be running on a 15-minute cron job or something like that. Yep. So the console client runs the health check on the server, not running. Right. Yeah, I'll cover health checks in more detail, but the question was the console client runs the health check on the local node, and the answer is yes. That's why everything runs on localhost. It's very local-oriented because the idea is to keep the health check as close as possible to the application itself. The health check would hopefully be checked in along with the application code. Yeah. So you can also use HTTP to query services. A lot of the tools built around Consul use HTTP. This is an example of what it looks like with curl. This is an array. This, of course, only returns one value, but it could just as easily return 4 or 10 or 500. And you see the same value is returned in JSON format with the UserDB service, the tag it's given, which can be multiple, as well as the port. You can do some customization around this. That's often what's done. But the third-party tools that are written to take advantage of Consul usually do use this HTTP interface. And again, this probably helps answer your question about the localhost services, because here we show that we're querying localhost 8500, where it's all served by. That query does eventually make its way up to the server cluster and back, but the local server is the broker, essentially, for that value. So the service monitoring. compatible with Nagios, which I mentioned. You can see the exit codes here on the bottom of the slide. 0 passes, 1 is warning, anything else fails. This is designed to scale to thousands of machines because it's a push-on-change only design. There is no polling that takes place, so you don't have to worry about, well, you know, the Nagios server is only able to poll, you know, 500 hosts before it falls over, or whatever it might be. And the fact that it's handling successes every 10 seconds is adding quite a bit of load. No, actually, there's an initial state that's published, and then the host the service is assumed to be healthy unless told otherwise. Now you might ask, well, what happens if something fails on the host itself? Well, we'll get to that in a minute. There is differentiation between service failure and failure of the node or the console agent itself. There's also kind of a cool option. I always like to say dead man switch. You know, I think of pirates and everything, but there's an option in the service checks to also basically allow services to publish their health to the console agent, so that if they don't check in within a certain time frame, it can be assumed down. So this is what the service checks look like. The examples, you know, especially at a conference like Scale, it usually kind of tells the whole story, I've found. The top is the interval-based check. You can see that's very similar to the JSON that was earlier. In this case, we're checking the memory of the host, doing it every 10 seconds, and that's an active check. If that basically starts failing, then the node will be deregistered from the service membership. And then the dead man switch, which they call TTL-based check, that's a little bit simpler. Basically, that provides a service name in the health check section of the HTTP API, so that if an application is interested in publishing its own service health for whatever reason, you might have a specific reason to do that, then we're setting what the timeout value is for that. If the app is publishing its service health, say, every 15 seconds, and you want to consider it dead if it doesn't check in in 30 seconds, then that's how it's done. So as I mentioned, how do we differentiate whether the service failed or whether console itself seg-faulted, or, you know, the host caught on fire, or whatever it might be? There's background gossip that's always taking place, again, through the Raft algorithm. And that's a constant load, that's a constant load and level of traffic, regardless of the size of the cluster. And basically, if that gossip communication fails, the node and all of its services are then assumed to be down. So it partitions off the service health from the node health itself. So that covers service discovery. Consul also, like the other tools I mentioned, has a hierarchical key value store. It's fairly straightforward if you've used etcd or some of the other tools like that, very similar. It's got an HTTP API. It's got long polling, which is kind of cool. You can do a HTTP-based query, and it will basically intentionally sit and block until there's changes to give back to you, so it won't return until there's changes to that value you are querying. There is eventually a hard timeout, but the idea is your application just does these very infrequent long polls to kind of subscribe to changes. And then there's distributed locking and ACLs, which I'll touch on a bit later. So getting into the tools that have been written for Consul, this is a fairly simple third-party. I can't remember if it's by HashiCorp or it's third-party, but you can see the power of the configuration store and the kind of triggers and subscription and polling with this tool. It sets environment variables, and if it watches a section of the key value store on changes. It sets environment variables to those values and optionally restarts the service. So in this case, we've got the user bin foo service. We're watching the section in the key value store called service/foo/config. As soon as that might change, you see we're initially setting the maximum connections to 256, environment to production. Maybe if we tweak maximum connections to 128, that will immediately trigger a reload, reset of the configuration value and a reload of the service. Although it is up to you to write the service wrapper to take advantage of those values. But yeah, that's a small price to pay for kind of the instantaneous updates, I think. Console template, that is a very popular wrapper for console service membership and key value store. Basically, it dynamically renders entire configuration file templates. As soon as, basically you can subscribe to either a particular service name or a set of configuration values in the key value store. And as soon as changes occur, it will write a configuration file and restart an application. So that's most commonly used with HAProxy, which is why it was originally called console-HAProxy, but they made it more generic. I've heard of people using it with Varnish and other tools that kind of require membership of service health and frequent changes. And it allows basically load balancer or HAProxy or any upstream subscriber to implement membership changes of only healthy nodes in real time. And this is what it looks like. I think picture's worth 1,000 words when it comes to these talks. But you can see this is an HAProxy basically server pool, what they call backend configuration. We're defining in this case the user DB service in HAProxy. We're doing both cases here where we're using the key value store, which is user DB/max connections again. We're setting that dynamically in addition to the membership of the service entitled app.userdb. So when we spit that through console template and wrap it for haproxy.conf, it comes up with the values in blue there, 32 for the max connections and a couple different members of that particular service. Now if we add DB3 or we take DB2 out of service, that will, as soon as DB3 publishes its healthy status with the cluster, all of the upstream clients will instantly get DB3 in their haproxy.conf. And haproxy will hop or whatever you might need it to do. Am I doing on time here? So now if we go back to the N-tier architecture, if you imagine something like haproxy, or at least the DNS-based service discovery on all of these nodes, you can see how if they each publish their own service and health to console, and everything else subscribes to it as needed, it becomes much more of a distributed solution than kind of the all-encompassing configuration management solution where suddenly, maybe if you're backing it with Git, you've got 250K of just managing service membership, and frankly, that scares me. So there's still a role with configuration management. I'm not saying one should replace the other. I'm just saying console complements configuration management well. You still need configuration management to deploy console itself. And you still need to deploy things like console template and the console template itself. And configuration management is great for that. At OpenX, we also need to assign like data center strings to deploy the console clusters and clients and such. So we use configuration management for that. It really looks pretty clean. There's not enough time in an hour's talk to talk about additional orchestration functionality of console, but you can certainly browse it on their website. They've also got an event system and a watcher-based system that can kind of allow for orchestration of participating nodes. Remote execution, a lot of stuff has that these days, but by running the agent, you do have the power to, CAD a file across all 500 healthy members of the foobar service or whatever it might be. And then the distributed locking, which I will touch on, because distributed locking is actually really handy. What a lot of people use Zookeeper for, which is kind of leader election, or wider lock management or multi-node lock management. There's a really simple single Python file. It's called console.do. If you Google it, I think you'll find the GitHub repo. Just one Python file that allows you to run one cron job, but only one cron job on multiple nodes. in our case specifically, we have a lot of use for this because there's often the situation where there might be an application with 20 nodes, but only one of those nodes needs to run an ETL job, but only one. You don't want more than one node writing ETL job. So you've got, that node's got to make sure it locks, run its ETL, remove the lock. This wrapper simply does the job automatically. You implement this cron tab on all 20 of those systems, and only one will ever run it. If that system ever fails, this has a lot of advantages because it gets tricky from an ops standpoint, I've found, when you've got like a 20-node cluster and 19 of them are fairly normal, but then that one node running the one unique cron job fails. And yeah, okay, maybe you can have a run book and great examples of how to replace and detect, the fact that that cron job failed. But there's still, maybe unless you've automated the heck out of it, there's still a human element involved to make sure that cron job gets moved to another host. This abstracts all of that, which I love. There's an optional web UI. It doesn't come with console by default. I just thought it was worth mentioning here. You can see the top-level boxes there that it provides. Kind of a nice little maybe executive or kind of screen-on-the-wall view into healthy services. What a lot of people might use negatives for, the dashboard there or something like that. Allows you to query the key value store, without mucking around on the command line. Although personally, I like mucking around on the command line. And then getting into a few more advanced topics, it does have an ACL system for security purposes. You can essentially, through a token-based system, control really kind of client-level access to specific services, specific functions, specific parts of the key value store, as you would expect. Crypto, basically the network there's two levels of encryption that it supports. It has a pretty simple pre-shared key value, a shared static pre-shared key that it can use to do synchronous encryption on the gossip and RPC communication itself. That you would typically want to use that in a cloud environment or an untrusted environment, very common in AWS, where you can't really trust the internode communication. And then it's got the capability to enforce certificate-based TLS authentication of clients against the server, against clients or clients talking to servers, I should say, and specific components of the API. We haven't delved into that too much, so I can't speak too much for it. But you can, if you're running your own certificate authority, basically you issue a client. You issue a certificate per client, and then you can perform authentication based on that. And then, of course, what talk wouldn't be complete without mentioning containers and Docker? That's kind of an interesting problem, actually. I've done some research on how that's done. Everything I've spoken about is sort of the multi-process system, but where you've got the console daemon running alongside your particular applications daemon and everything else. Well, with containers, you don't really want to do that. I've found with containers, if you're running more than one process, you better have a good reason, because otherwise you might be doing containers wrong. So we certainly don't want to run the console binary in the same container as every single container providing a service. You can Google. There's I think a console-docker GitHub page that talks about kind of the architecture of running with containers. But essentially it involves running a console container alongside the rest of the containers on a particular machine or node. And then that console agent listens with like DNS on the Docker.0 network interface. It also has some advanced functionality like reusing the network state and the socket of the containers themselves, so that you can still run the health checks kind of in a local context. You can do ephemeral. You can spin up ephemeral containers purely to run health checks, kind of in the space of an existing running container. It's pretty interesting, but it could probably be its own talk itself. Definitely worthy of more exploration. So I gave this talk at OpenX kind of to prepare for this, and got the great feedback that, hey, it sounds like the best thing since sliced bread, but you didn't talk about any of the potential pitfalls or problems. So I made sure to add this. There definitely are some things we're working out and that do concern me. We call this, or I call this, actually, Anthony Molinaro at OpenX calls this the Skynet problem, I think, and I think that's a good way to look at it. When you get too smart, you don't want, well, okay, the console cluster is not going to send a cyborg to murder us, but still, if you have some sort of human failure or system failure, let's say you're running console template everywhere and using service discovery extensively, what happens if all of a sudden all of the nodes in a service, deregister and you're left with maybe 0 or 1 or what have you, basically too few capacity to serve that particular service. I haven't seen much built-in functionality for that. I think what we're going to have to wind up doing is writing essentially a more involved console template type function. It also applies to the configuration store. If you have an invalid configuration file, I haven't seen, to my knowledge, any configuration sanity checks before basically writing the output of a template and restarting a service. If max cons is set to 128, great. But what happens if you set max cons to blue or something like that? You certainly don't want to restart your service, have it fail, and have that cascade instantly across your entire environment. So I think there's definitely some space to account for kind of the worst case scenarios and be a little bit more, considering that all these changes are happening instantly, which is both a good and incredibly scary thing. I think there's a lot of room for paranoia in how this is done. And then security, I have some security background, and this is quite a security vector as well. If an attacker were to get on a node participating in console and you haven't really locked everything down, an attacker might be able to publish a node as part of every service and just get all the traffic and see what happens. It's definitely a worrisome vector, or overwrite the values in the key value store to nefarious things. And then I mentioned the remote execution. That's terrifying as well from a security standpoint. If somebody, even accidentally, but whether intentional or by accident, hopefully you're not running console as root, but still, you got to be careful when you've got the capability for this particular piece of software to execute a command on 5,000 nodes, immediately. That's worrisome. The same applies to configuration management, but I think the difference here is the distribution of the console agent versus the fairly tight scope of the typical configuration management server, which it might have, might be backed by Subversion or GitHub and maybe have some peer review processes involved. That doesn't apply in this case. Maybe it could, but it needs further consideration. I mentioned some of the Skynet issues with console template, but the template, it uses the Go templating language, and probably by design it's very simple. If you want to do anything kind of other than what it supports, you're out of luck. You're probably better off writing your own wrapper. So that's a little bit limited. We've had situations where we just have like specific architecture reasons to maybe weight certain nodes differently, or to go to localhost for every other request. That's one example in ours. And console template doesn't really support that sort of logic. It's just a dumb, provide the healthy nodes in a service, and that's it, which is a good thing. Limitations are good, but sorry, question. Yeah. Yes. The question was the example I showed with console template didn't specify whether HA proxy would be reloaded or restarted, or really how that works at all. Does it send a HUP? Does it just put a command line value of reload or restart? Actually, I didn't have a chance to look that up. Anybody know? Anybody from the audience know the answer to that one? I don't know it off the top of my head. I think it just runs. I think it gives it a command line value of probably either reload or restart. That might be configurable, but I'm assuming it's expecting what amounts to an init script or the equivalent thereof. That's actually a good question too. We were thinking about that some randomization would probably be a good thing. The instantaneous nature of it could create some thundering herd problems. I haven't seen it built in. When I talk about the limitations of it, that's another example where I think we'll probably wind up writing our own wrapper. Yeah. And then one last thing that worries me a little bit security related, is it's very real-time oriented. If you're troubleshooting something weird that happened at 3 a.m. last night, and you want to know what healthy nodes were part of this service at 3 a.m., not now, I'll be honest, I haven't investigated this in great detail, but there's not a whole, versus configuration management, if it's backed by version control, you just look at the commit history. Even if a machine is doing it, you've probably got a commit log. Not too much with console, so this is worthy of investigation. It does have very verbose logs, so perhaps capturing those logs and maybe even writing a tool to kind of interpret them a bit better, abstract them into kind of a time state would be pretty cool. So how are we doing console at OpenX? Well, we're not in production yet. It is just version 0.5. I scheduled this talk because I'm just excited about the way this is done versus kind of the mega software that configuration management is these days. We do have server clusters up. My philosophy is you can deploy it now and just publish everything. There is no harm in publishing services. It's only when you start consuming services that you have to start worrying. So you could use it just now as a health dashboard. And then later, if you want services to consume them, you can add that as needed or roll it out very slowly. But so my advice and the way we're thinking is to just publish everything right away and get our health checks right. And that'll have other kind of cascading good effects as well, writing good local health checks, especially in a scalable way. We do deploy console with Salt. We use Supervisor D because we're not on any System D-based or Upstart-based system at this time. There's kind of a question about how to handle multiple environments. I could have put this in the concerns section. You might not want to mix service membership of QA versus staging versus dev versus devint versus production. There's a few schools of thought on how to do this. The official console author answer is to run separate clusters per environment. I'm not super excited about that. We can spin them up pretty quickly now, so maybe it's not such a bad thing. The other option is, well, you could just put the service name in put the environment name in the service name. That's a little bit hokey and still prone to human error. You can also use tags. So my example of RO for the read-only tag, you could do tags staging and RO. The problem is you can't do queries on multiple tags, so you can't get the read-only server in the staging environment using tags. There's an open issue I filed about that, which is getting some traction. I mentioned the limitations of console template. I don't know if you guys have packaged or deployed software written in Go, but it is extremely pleasant. There's not really a lot of dependencies because they tend to be standalone binaries. It was astutely pointed out that that's actually a blessing and a curse because it essentially means it's statically compiled. So when we've got something like a glibc vulnerability, very topical, just updating system glibc may not help you in Go software, so you might want to check that out. And I'll quote Chris at OpenX, we need to unleash the chaos monkey on console and see what happens when it's got intermittent network or when we randomly, just shut down a box or, we hammer it with 5,000 service membership requests in the span of a second and that sort of thing. So we're kind of in the intermediate stages of deployment. A couple quotes from HashiCorp. They call it batteries included data center control plane. Batteries included meaning kind of the fact that it's opinionated versus the other tools, which are essentially, oh, you want a car, here's all the parts for the car, build them, or here's a machine press, build the car parts and the car. It's opinionated. If you don't agree with its opinions, don't use it. I happen to, because specifically the abstraction it does with services is what I'm interested in. If you want more of a raw key value store, some of the functions elsewhere, and you don't care about services, maybe it's not the tool for you. But that's okay. Works at scale. Basically, this is more of a philosophical thing, but it's lightweight, it's distributed, it does, well, maybe two things well instead of one thing well. But, I like it as a complement to configuration management so that you don't have all your eggs in one basket, so to speak. And that's all I got. Anybody have questions? Yep. The question is there load balancing based on other traits other than round robin? I believe the answer is no. So you'd have to write. You could publish tags probably based on that and make decisions. Yeah, but I don't think it supports that out of the box. There'd probably be a way to hack around it, but not out of the box. Yeah. Yep. Yeah, question is, does it help you distribute essentially credentials for the applications themselves? Yes. I know some people actually have spoken on the console, or written on the console mailing list that they're doing that. I haven't explored it myself. You would probably have to write your own crypto. I don't think it supports encrypting values in the key value store natively. So you would probably want to wrap it with GPG or something. I don't think you'd want to store raw, database passwords or what have you in the key value store itself. But yeah, really anything that's a configuration value you can store in it. Yeah, but I mentioned it is opinionated and abstracted, but yeah, maybe somebody will come out with a wrapper tool to do that sort of thing with the crypto wrapper. I would certainly like to see that. It's a great use case. Yep. Yeah. Question is, how much key value data can you store? Can you store like server metrics in it? I would use like OpenTSDB for that. I've heard mention of like this just comes to mind, like 50,000 values, something like that. It scales pretty heavily. There's been interest in putting like business data in it, not just kind of DevOps type, technology data. Customer information could be one example. Hopefully not personally identifiable customer information unless you encrypt it. But yeah, I would definitely use an alternative key value store for metrics, unless it's super simple. Yeah, put the data then in, then have something else suck it out. I don't know. Then you're going against my avoid complexity philosophy. So you could do that, but might as well just write to another database directly. Is the way I look at it. Yeah. Yep. You're thinking about what? I didn't get you. Yeah, the question was, can a node change basically its service publication values, essentially? So if a Postgres node takes over, read-write kind of mastership, can it change its tag from RO to RW, for example? Absolutely. It would really just be a matter of changing the JSON file, because I believe console automatically picks up changes to those files. You would have to, outside of console, have something to change those values, though. But that would be pretty lightweight. Yeah, and I mean that's where configuration management can come into play too. There's certainly still a role for that. Yep. Yeah. Question is, does console provide a metrics endpoint, such as So to track like number of nodes, maybe high watermark at a given time, graph it. I'm trying to remember. I think I've seen it actually in their built-in UI that it does have some notion of that. Um, I'm almost positive that's in the HTTP API. So I think any node in the cluster you query, you should be able to get that. Now, is it an exact value of like, I don't think they're going to give you like high watermark in the last hour or anything fancy like that. But you can probably, you might have to worst case query the service and, worst case you'd have to query the service and count the size of the array it returns. But I wouldn't be surprised if it has metrics for that. If not, I'm sure they're working on it because metrics is everything. Yeah. Yeah. Why do we need 5 servers and not 3? Console has, when console drops down to 2 servers, depending on how it arrived at those 2 servers, it will go into basically this emergency mode. If a node if a node in a 3-node cluster ungracefully leaves, I believe it still functions and gives some probably nasty log messages, but still functions normally. If you gracefully remove the 3rd node, or node number 3 in a 3-node cluster, console does not consider 2 nodes to be essentially quorum, which is required for the consensus algorithm, and it will basically degrade. Well, yeah, the question was, do you have to configure the client with the 5 names of your servers? No. The way we've kind of orchestrated it in Salt is when we're spinning up the cluster, any one new member needs to know is the one IP or host name of another member of any function, client or server, because then the rest of the cluster is discovered. So you could give it all 5 values just to be safe, but the command is actually console. If you install and run console, and then you do console space join space IP or host name, just that one value, as long as it's a functioning node on the other side, auto discovers the entire cluster. Yeah. So actually what we do, I think, is we check the exit value of the console join command. We just cycle through the known host names of our cluster, and as soon as the first one that succeeds, we're good, and we stop. Do we have any failure with the cluster? Well, we haven't. The question was, do we have any failure of our cluster blowing up, anything like that? When I mentioned we need to unleash the chaos monkey, we haven't really tested it to a great degree in that respect yet. We haven't seen any random seg faults or any instability in that respect. But we also haven't put it through like hardcore production paces yet either. HashiCorp says that there are customers out there already running multi-thousand node clusters in production. So for more information about that, I think there's some stuff on the website of like reference customers. Yep. Yes. Question, can you back up the key value store? Yes. You actually give it, one of the startup options or the configuration file options is basically the data directory where it stores service membership, key value store, all that information. Those files you can back up. You can copy them to shared storage, whatever you need to do. Those files can be used to recover from a, massive outage. You can basically bring up a cluster using the saved state files. Yeah, so backing up those is definitely a good idea in a worst case scenario. Okay, well, that's it. Thanks.